And I guess we'll start out, keep everyone on time here. We're going to start with Dr. Laura Ingwell, and she's going to talk about some cucurbits and insect issues with those. So I'll turn it over to her.
Thank you, Phil. Hopefully y'all can see my screen. It's a little bit of a delay. There we go. Okay, I'm starting off with a poll question, so hopefully my moderators aren't too distracted. Oh yeah, there we are. Okay, so I am giving sort of a, well, this is not my question. Oh, that's a welcome question. You want to leave those up, or are we gonna?
Sorry about that. You want your first?
Yeah.
The cucurbit insect pest control?
Yes.
Here we go. Sorry about that.
That's okay. Okay, so the first question that I'm interested in asking all of you is, which is the most damaging of the insects that are listed here in your cucurbit production? So I have a little bit of an abbreviated form on the slides I'm showing you, but the first option is striped or spotted cucumber beetles. The second option is squash bugs. The third is squash vine borer. The fourth is aphids. And lastly is spider mites. Or none of these. And I'm asking you this, it'll sort of dictate how much time I spend, but I'm going to introduce you to a little bit of the biology and background of each of these pests, and then spend the majority of my talk showing you how to use the Midwest Veg Production Guide and talking about your management options for this suite of insects. So I don't know, it'd be good if we can get at least 50% voted before we close the poll.
We're currently at 37, Laura.
Can I move ahead, or we have to wait? Can you leave it open while I talk, I guess, is the question?
I think so. Try advancing your slide, maybe.
Okay. Oh, no.
Okay. Do you want me to end the polling? You're at 53.
Oh, wait. No, here it goes.
Oh, okay.
Okay.
Let me know when you want to end the polling.
Okay. I can see that there. Okay, so the first insect that I wanted to talk about is aphids, which is fairly low on the priority right now. That's good. I won't spend a lot of time. The key thing is really understanding their life cycle and how they do not really change in appearance as they grow. So aphids undergo something called incomplete metamorphosis, which means that the juveniles look like the adults. The one thing that can be a bit tricky is that sometimes aphids have wings and sometimes they do not. So what I'm showing you pictured here is a bit of the variation that you can see within a single species of aphid. So color can often differ. Here we have green and pink types. The size is just showing you what the nymphs look like. So nymphs will come out of a reproductive female. There are no eggs in the situations in which you're encountering them in your crops. And sometimes they have wings, usually when the food quality gets low or when the population is overcrowded. That's their main way of dispersing long distances, is using those wings. They feed with piercing, sucking mouth parts, so you won't see holes in the vegetation. But what they do is they feed directly on the phloem and they excrete excess sugar from that feeding strategy. And so what you will see on the leaves below where the insects are is this shiny sheath over the leaf, which is like honeydew or excess, it's their urine essentially. And then eventually sooty mold grows on it. So it's problematic because it blocks the plant's ability to photosynthesize. And most often in field situations, if you're not using a lot of foliar chemical applications, there is really a wide variety of natural enemies that can suppress these populations. And so what I'm showing you here is just a snapshot of some of the most common that we find. Parasitoids lay their eggs and the insect develops inside the aphid body. So you end up with the carcass of the aphid being left behind. But what you have to be aware of is it's inflated and no longer feeding. So that's not necessarily damaging the plant anymore. and quite a few other generalist predators that will munch on them. But what is also actually the main contributor to their mortality in the field is rain. So if you have really heavy rain, it actually dislodges and knocks them off the plant. One strategy, behavioral strategy to avoid that is to feed on the underside of the leaves. So you often, if you're scouting in your field, have to flip that leaf over to look for them. Sorry. The next pest I want to talk about isn't actually an insect, but it falls within our wheelhouse, and that is mites. This one I know is especially problematic for some of our melon growers down south. They really like hot and dry weather, so they become a problem later in the summer. They are dispersed on the wind, so they can enter the field along the field margins for the most part, and they do really well on drought-stressed plants. And the key to managing mites is really early detection. So what you can see early on is this sort of stippling of the leaves. It starts on the underside. When the populations get higher, you can see the stippling on the upper side of the leaf as well. It's this yellow coloring. And under really, really high infestations where there's very little opportunity to rescue the crop, you get this webbing and the leaves are just completely desiccated and drying off. So early intervention in controlled environments, so if you're growing in high tunnels or greenhouses, really being meticulous and looking for early signs and then implementing biological control or chemical control is key. Again, in the field, rainfall is a big factor, and so sometimes timing of rainfall events can actually prevent infestations in your fields. This past year, we had very few problems with mites in field production situations. And you can close the poll. I think it hasn't moved in a bit. So the #1 pest that y'all voted on are striped and spotted cucumber beetles. We are getting there. White flies, I'm going to zip through. I don't even think I had them on my list. Hold on. I'm gonna get rid of that. I hope I didn't lose your poll, but it's not letting me go forward. Here we go. Okay, they're really usually a minor concern in the region, but can become a problem in protected systems. So again, greenhouses and high tunnels. This is an infestation that we experienced on cucumbers in a high tunnel a few years ago. Most importantly for whiteflies is that they can vector viruses. So just having a good scouting protocol in place is important for this pest. Squash bugs, I want to take a little bit more time on. This is one I hear about a lot. So they are a true bug. They feed in a similar fashion as aphids with piercing, sucking mouth parts. They have actually a very large beak that you can see if you pick them up. Like a lot of the pests that we're talking about today, they are native to the region. The adults overwinter in vegetation, and as it warms up, they begin flying around and moving into crops. They have a very distinctive egg mass that they lay on the plant, and it can be found in various positions on the stems, on the leaves, undersides of leaves, and sometimes on fruit. But what is really identifiable is that they are clustered often in very parallel lines, and they are that dark bronze color. The nymphs hatch out of those eggs, and they look very similar. The color structure is different, but body shape is pretty similar as they increase in size. So it's close to an aphid, except that all squash bugs have wings. So what you can see here is the development of these little wing pads forming. So in the last few stages, they start to look a little more square and boxy like the adults. They're problematic for a number of reasons. One is that they have a toxin in their saliva, so when they're feeding on the plant, it causes wilting, and then they can feed on the fruit. The eggs take 10 days to hatch, and with that being said, if you're going to try to control them with a pesticide, you need to time the application so that you're getting these little baby nymphs that come out. This is when they're most susceptible. So really scouting, watching for those eggs, and understanding that hatch is going to be really important. And then cucumber beetles. So I'm going to assume you all know what they look like because it was your number one. The reason they're so problematic is because they transmit bacterial wilt. In some cucurbits, this is an issue. So when we are talking about cucumbers and cantaloupe, we have a very low threshold of 1 beetle per plant is what we can tolerate. If you're growing something like squash and pumpkin, those cucurbit crops are resistant to the bacteria. So in that situation, it's the direct damage and feeding on the fruit that's problematic, but you won't lose the plant to wilt. And so we have worked in this crop with this pest for quite a few years and have really developed some detailed scouting efforts to be able to detect these thresholds. And so what you want to do here is you want to scout on a weekly basis in your field. We worked a lot with watermelon and operating under the threshold of 5 beetles per plant. That requires you to evaluate 7 plants within your fields. And what we recommend is starting at the edge and just walking in a parallel line and sampling 1 every 15 plants until you hit that 7 plant mark. And within that 7 plants, you have a 95% confidence that you will be able to detect those 5 beetles per plant and make a recommendation. So it really does not take very long, about 20 minutes, much quicker when the plants are smaller. So that's the average time for 8 plants to detect this. If you are growing something like cucumber or cantaloupe, that threshold goes much lower to 1. And here the number of plants increases to get at that density of beetles, so 26. So in something like cucumbers or cantaloupe, maybe scouting isn't as economically feasible. And squash vine borer is another pest I'm going to fly over because we don't have much time. If you want to put up the poll question here, this is my second one. I'm just going to talk briefly about these and then go over some of your insecticide options. So there are some cultural practices that can be effective depending again on the type of cucurbit. For instance, delayed planting can be very effective if we're talking about cucumbers. And you want to miss that first window of cucumber beetles. So we have 2 peaks of that population. We have the overwintering adults that in spring will fly out and look for a suitable host. They have to find a cucurbit to feed on. And so if you can delay that planting past that emergence of the beetle, then you miss that first wave and don't have to worry about damage on those young seedlings. Resistant or tolerant varieties are sometimes available, but definitely not for cucumber beetles. There may be alterations to tillage practices that you can do, and that just has to do with timing of tilling or intensity of tilling, which can impact alternative plants for the insects. This is not the right question.
That's the next poll that I have.
So,
okay. That's
Laura,
okay. We're going to move on because
Laura, they had answered this question already.
Oh, what was the answer?
That's what I was sharing the results. We're getting it. There we go.
Oh, okay, going down.
Oh, gotcha.
Selection of resistant and tolerant varieties. Okay, awesome. And then delayed planting, and some of you don't do any cultural. Okay, I want to get to the, okay, this is the most valuable tool. I use it all the time to help provide recommendations, so I want to make sure that all of you know how to use it as well. And Dan, Egel, and I are going to produce a video, so I just want to go through the results of what it looks like for the crops and the pests we're working on, since we are very short on time from starting late. So using that tool, which is our ID 56 Midwest Vegetable Production Guide, which is updated every year, you can go online and you can search specifically for whatever cucurbit crop you're looking for, whatever the pest may be, and you can even do multiple pests. So what I've done here is I've taken that information and I've pulled it out and compiled it into a table to make some comparisons or be able to take a snapshot and look at all of the different chemistries available. So this is by active ingredient here. or also related to the IRAC code, which is Insecticide Resistance Action Committee. So this has to do with rotating to different groups of insecticides to avoid resistance. So it's a broad way to group our chemicals together. And some important things that I want to pull out and show you is that mites are often in sort of a group of their own. Like I said, they're not insects. They feed in a little bit different strategy. So the miticides are often labeled and sort of independent products, but some of the other chemistries we have can be effective at controlling multiple pests. And that gets into the feeding strategy. So aphids and whiteflies are true bugs and have piercing, sucking mouth parts. Some of the products that are effective against those pests can also be effective against squash bugs. And then you get cucumber beetles, which are chewing insects, kind of again in their own place. Some of the things that you really want to consider when you're selecting the chemistry may be the impact on pollinators, and we will talk about that and the last talk today, myself and Dr. Long. But there's a lot of variation among these chemicals in terms of their impact on pollinators. So when you're trying to make a decision about which chemical to use, if it's close to flowering, I highly recommend paying attention to this bee precaution. I also think that if you're targeting a particular organism using some of the newer chemistries that are designed specifically for that type of organism can be really effective. So something like bee leaf here is the active ingredient is flunicamide, and it targets piercing, sucking insects. So that is aphids and whiteflies and has a little bit of residual activity for squash bugs in the field. Some of the other products that are newer and show good control include this bottom class, this IRAC code of 28, Harvanta or Exaril. And the main take home that I want to tell you here is that I've dug through the literature and looked at all of the information we have on efficacy. And we really see from published results similar efficacy among all of these groups. So we don't see a lot of difference between using carbaryl or a neonic compared to a pyrethroid. So looking at the timing of when you're applying this to the crop can be really important in terms of other non-target impacts like on pollinators. Maybe I have 1 minute for questions, but here is the website to find all of these publications and get to that guide. And we also have a new high tunnel cucumber production guide available, which you can find online as well. Sorry for going so fast because of the time constraint.
Well, thank you so much, Dr. Laura Ingwell. So we are going, because there are so many people here, we're just going to ask everyone to put questions in the chat. And since we did start late due to technical difficulties, we won't take an official Q&A break between these sessions. If Dr. Dan Egel wants to start sharing his screen with his presentation, Dr. Dan Egel will talk about cucurbit disease updates. But throughout the presentation, please feel free to put your questions in the chat. And if any don't get answered during this series, we will answer them later via email. Laura, we did have someone ask to show the last slide. Maybe I think it's your contact info.
Yeah, I got it, Rebecca. I'll respond and put stuff in the chat.
Great, thank you. Okay, we can see your slides, Dr. Egel. Feel free to get started. And feel free to let me know when you want a poll given. We can't hear you if you're talking.
When you do the share, make sure you click on the share computer audio.
Hello, my name is Dan Egel. I'm the vegetables disease specialist for Indiana. I work in the botany and plant pathology department at Purdue University. I am located in the southwestern portion of the state where there's a lot of cucurbits grown. Today I want to talk about a cucurbit disease update for 2021. So today I will talk about a couple of emerging diseases which I feel like have been important in the last few years and I expect to be important this coming year. I will talk about management strategies for those diseases, and I'll give a couple of fungicide updates for some new, just 2 new fungicides that have been recently labeled, and I'll end with some resources so you can look some stuff up later if you want. So the first disease I'll talk about then is Anthracnose of Watermelon. You see on the left that there's jagged, angular, rather dark looking lesions with yellow halos around them. These lesions can be severe and defoliate the plant, and in that case, when the vine's defoliated, it can cause a loss of fruit quality and a loss of yield. But as you'll see on the right, you'll see lesions of anthracnose directly on the fruit. Obviously, this will cause yield loss. But in addition to this, smaller lesions, especially when they occur on the bottom of the fruit, can be easily missed, loaded into your truck, and they can cause problems post-harvest. This is Anthracnose of Cantaloupe now. You see the lesion on the leaf on the left of cantaloupe leaf. It's not as dark, not as jagged looking, but still anthracnose can cause defoliation of cantaloupe in severe cases. And on the right, you'll see lesions of anthracnose directly on the cantaloupe fruit. My experience is that there are some cantaloupe that are more susceptible than others in some varieties. So anthracnose of cucurbits, my recommendations are scout transplants, whether you're growing them or receiving them after a shipment. Scout them for symptoms of anthracnose. The disease can come in on transplants and can come in on seeds. So you want to use seeds that have been tested for anthracnose. Crop rotation is important because the disease can last on crop residue in the field, while tillage is important. Apply fungicides prior to disease. In most cases, I would apply fungicides by the time vines touch within the row. I recommend a 7 to 14 day schedule, more frequently when the weather has been rainy and when it's been drier. You can spread those out to every 14 days. If you're interested in using a weather-based disease forecasting system, at Purdue we have the Melcast system, and I'll have a website you can visit, or you can ask questions about this later. Fungicide applications via Melcast, you'd use a weather-based system instead of a calendar-based system. So this is systemic. This chart here, table is the systemic fungicides recommended for use of anthracnose. Fungicides that would move within the plant then. So you have on first column is your trade name, your product, then your active ingredient, your FRAC or mode of action group. FRAC stands for Fungicide Resistance Action Committee. And then your re-entry interval and pre-harvest interval is included here. So you see here that there's a lot of group 11s listed. Group 11s are largely effective against anthracnose, but you want to avoid using group 11s back to back in sprays in sequence, and we'll talk about how to avoid that in a little bit. But you'll also notice the Thompson here is on my recommended list, and it's a number 1. There's also some fungicides which don't move in the plant, fungicides which are what I call contact fungicides, which will be effective if they contact the fungus on the surface of the leaf. So first we have products with the active ingredient chlorothalonil, and then products with the active ingredient mancozeb. Both are in an M-frac group, which means that you can spray those back to back in sequence, that is, without worrying about causing fungicide resistance in the pathogen population. So if you wanted to make the body of your sprays a contact, for example, this is from May to June, kind of a simulated spray schedule here. So you have Bravo in red here, spray all season. In this case, we've decided to put systemics in twice. We've decided to use the systemic product Pristine. It has 2 active ingredients, a 7 and 11. And so we're not spraying it back to back. We're spraying Bravo in between there. Or if we wanted to use 2 systemics back to back, here we have Pristine with frac group 7 and 11, and then tops in group 1. We could put those back to back without worrying about fungicide resistance. So Phytophthora blight of cucurbits is the next disease I wanted to talk about. Phytophthora causes nasty looking lesions on watermelon, often starts at the bottom, and that's shown here. It can cause large lesions like this or smaller lesions which you could miss and perhaps load into your shipment. But Phytophthora does not, for the most part, does not cause any problems on the vine itself. So that will affect the timing of when you have to spray for Phytophthora on the watermelon. On the other hand, Phytophthora blight of pumpkin not only causes a lesion on the pumpkin fruit, as you see in the right in the lower corner, but also on vines, and you see the vines dying there from Phytophthora. So for Phytophthora blight of cucurbits, I recommend crop rotation, whereas a 2 to 3 year rotation is good enough for Anthracnose. Probably a longer, at least a 4 year rotation is better for Phytophthora. It has a long-lived spore, which long-lived in the soil. Avoid peppers in the rotation because peppers are very susceptible. Water management is critical. Use well-drained fields if you can. Avoid those fields that have spots which puddle. Use raised beds if possible because the water will run off. Drip irrigation is preferable to overhead irrigation. Apply fungicides prior to disease, and we'll talk about that in a moment here. Especially fungicides, the fungicides which are effective against Phytophthora are not necessarily the ones that we spray for Anthracnose, gummy stem layer, powdery mildew, for example. For watermelon, since the disease does not affect vines, you don't need to start applying fungicides until it gets to about the softball stage. Then with pumpkins, since it does affect the vine, I would apply your first fungicide at least by the bush stage. After that, and by the bush stage, I mean when the pumpkin plant is grown up before it starts to vine. After that, you can kind of go by the weather a little bit. Milkcast does not work for Phytophthora, but certainly with rainy weather, the disease will certainly be worse. So systemic fungicides recommended for Phytophthora blight of cucurbits are shown here. Same as the last table. The first 3 I would be products that I would recommend using at what I call the softball stage for watermelons or for pumpkins, the bush stage. So that would be the phosphorus acid products shown here, Actigard or Forum. After that, you would want to alternate using the rest of these products shown here. I'll talk a little bit more about these, but I'll just point out here that several of these have a group 40, and you would want to avoid 40 is great, but don't use those back to back. Don't apply group 40s back to back. So here, this is some examples of just how you might rotate these. This is based on a study we did a few years ago. The first one takes Zampro and alternates it with Orandus Ridimel Gold. The Ridimel part of the Orandus Ridimel Gold some isolates of Phytophthora are resistant to Ridimel, but since it's a tank mix of the Arondis product and the Ridimel product, you'll be okay. And in addition to that, you're alternating it with Zampro. The second option is to alternate Rebus and Presidio all season long. And then the third option is a little bit more complicated. Use Actigard first, then a tank mix of Ranman and the Ridimel Gold, Presidio, Illumin, and then the final one would be Arondis Gold, Ridimel Gold, or Arondis Ultra. Now this is complicated, but my feeling is that in general, the more modes of action you get in there, for the most part, the better. Now the first one, the Actigard, I'm suggesting here you could substitute Forum or one of the phosphorus acid products there instead of Actigard if you want. So I mentioned water management, and you see here on the left of the watermelon field, which has water between the rows. This is the kind of thing you want to avoid, as this will can cause Phytophthora to be quite severe. On the right-hand side, you don't see water in the row, but you can see by the caking and cracking on the soil where water has stood, and you can see that the vines, the pumpkin vines, have died there. And I should mention that if you're going to put raised beds and plastic on, that you want to make that plastic domed so the water runs off. And just a sanitation suggestion: this grower has taken watermelon and his whole watermelon, put them back in a production field, and red arrows indicate some of these watermelons have Phytophthora symptoms. So the next time that grower goes back in this field, Phytophthora may be even worse. So watch where you put those coal watermelons. You want to avoid putting them in anywhere close to a production. A couple of recent fungicides that have been labeled. Gatton shown here for powdery mildew of cucurbits. I show a powdery mildew on a pumpkin leaf and then watermelon fruit. Normally, powdery mildew is worse on pumpkin than watermelon, but it's something to watch on watermelon as well. I show the active ingredient and the REI PHI information here. Crack group U13, which is new, which is recent, and we're always looking for new modes of action for powdery mildew, because fungicide resistance can be a problem with that disease. The other one I wanted to talk about is Prolevo 300 SC for powdery mildew. This is the active ingredient in the REI PHI information. Crack group 50, which is relatively recent, and it's silent for greenhouse use. So if you want to use the greenhouse use, silent means that you could use it in the greenhouse. And if you wanted to use it, that would the crop you probably want to use it on would be cucumber, and some cucumber varieties are susceptible to powdery mildew. Finally, I wanted to show some resources. The Midwest Vegetable Production Guide is shown here with the website, the URL, mwvegguide with 1g.org. We will not be producing hard copies this year because of the pandemic, but the guide is searchable on your phone or on your computer. And if you want to download a guide, I can walk you through that if you give me a call, and you can download the whole thing or portions of it and then print it off for yourself. But I can help you with that. A couple fungicide guides are listed, and the websites for these are listed. That tells you kind of what fungicides that I think should be used, but then also the order that those fungicides should be used. If you want information about Melcast, you can ask me questions at the end of the presentation, but melcast.info is the website that you would want to visit in season. And then I list 2 extension bulletins that kind of put in writing some of the things which I talked about here for Anthracnose and then Phytophthora of Cucurbits. And then finally, my contact information is shown here, and I'll be glad to answer any questions at my email or my phone number, or if you have any questions now, I will be glad to answer them.
Thank you, Dr. Egel. We do have one question in the chat. As a small organic farmer, can you use copper fungicide to treat or prevent Phytophthora?
So if I was a small organic farmer, certainly copper products is one of the first things I'd look for. But you have to, if you are certified organic, some copper products are certified and some aren't, so you'll have to check with your certifier, but yes.
Okay, thank you. That's the only question we currently have in the chat. Again, if you have questions throughout the presentation, please feel free to type those in the chat. If there are no other current questions, we'll take time for a sponsor break.
There's an Austin Ferguson that indicated he wants PARP credit. We don't have him in the system, so he needs to share in chat his contact information.
Okay, will do. Thanks.
Hey, Lori, can you hear me?
Which helps them
Yes.
pack out their 40 count bins.
Do you think that we should launch our welcome poll? There's a question about people were wondering primarily what people grew. Would you like to launch that poll during this break?
There's nothing quite like fresh, sweet, and
I'm actually not hearing you with the
select from. Rub Seeds can help you grow perfect ears for
Hang
your
on just a
customers.
sec.
If you need a cold soil tolerant variety to hit the early market, one that will stand up to shipping, or one with great flavor that will keep your customers wanting more, our team can help you put together a plan to produce great sweet corn all season long. Visit rubseeds.com or call 800-700-1199 to learn more.
What was that?
Sorry, I was wondering, since we didn't launch the poll at the very beginning, I didn't know if we wanted to launch it during the break.
Yeah. Maybe right after this runs through.
Yeah, I think that's fine. Becca, do you know how to do that? Okay.
We can't hear the audio with the sponsor video. I'm guessing it's because Lori, you're muted maybe.
For farm workers are also eligible for technical assistance free of charge. You can contact me, Brandon Lean, at 765-286-2162 or BLIEN@pathstone.org. Thank you.
Please consider participating in the poll that's on the screen now. And in the interest of time, we should move on to the next presentation. I don't know if possible, we can keep the poll open just for another 30 seconds or so. And if Lori, if you want to stop sharing, and then we'll have Joe Rorick and Dr. Liz Maynard talking with us today about case studies and planter adjustments for no-till sweet corn and pumpkin. So we will be talking about pumpkins. Oh, we're seeing speaker notes.
So close, sorry, hang on.
Someone had to do it.
Yeah. Nope, that's the wrong one still.
Go to the, there we go.
There we go. Thanks.
Okay, and I'm going to end this poll.
And I think we have a poll to start with. Should be a question about planter setup.
So it looks like most people are grow cucurbits commercially, and then nightshades, it looks like. So we will stop sharing those results and go to, are you the pre-case studies?
Yes.
This one. Okay. So if everyone could take time to answer this poll that's on the screen now.
Oh, good. At least one person. Oh, two people took the bait question. Good.
Great.
The bait response.
That is great. So, well, people are answering that. I think I can get going with the talk, right? So we're, thanks for joining us this afternoon. I think I recognize a lot of names. I'm Liz Maynard in horticulture at Purdue, and together with Joe, conservation agronomist with Purdue Extension, we're going to talk about some planter adjustments for no-till pumpkins and sweet corn. And anyone who's done no-till, or even if you haven't, you know the setup using a conventional tillage might not work quite as well. It's a different system. And you've got to have a good stand, otherwise that no-till system just isn't going to work. So we had a couple of examples of some simple trials that were done to kind of figure out how to get a better stand. And the first trial we're looking at involves planting pumpkins into a cover crop of rye before rolling it. It's what you see in the pictures here. So the pumpkins are planted through that, and then the rye rolled afterwards. A grower had mentioned that they were trying some different closing wheels on the planter because it had seemed to them that the pumpkin seeds weren't getting covered well by the standard closing wheels, and so that was resulting in poor stands. So Joe and I had the opportunity to work with them to set up some strips where we could actually take some data on the closing wheels. I think Joe's got some information on closing wheels in the next slide.
I do, yeah. And I guess in the interest of full disclosure, we are not going to recommend to you which closing wheels you should be using. So if you think that's where we're headed, I'm sorry, but you're going to end up disappointed because of what you see here on the slide, right? There's roughly 10 closing wheel companies. There are in the neighborhood of 25 unique wheel types. There's a couple of mounting positions and different force settings that you can use. And all of that adds up to thousands of options per row. So then you multiply that across however many rows you have on your planter, and that's what you can do on your planter. And so there isn't any one option that's going to fit. So the idea is just that you need to be testing these, and you need to check out what's going to work for you and on your farm, in your fields, in your soil conditions, all of those sorts of things.
So we wanted to show you this field layout of how we set it up. We went down there like the day they were planting, and it was pretty simple to set up just a few planter passes where we could collect data. And so what we did was we counted out 100 seeds per row for each pass. Rows were 6 feet apart, so they had 3 rows per pass. And in one direction, there were 3 closing wheel types, and in the other, there were 2 closing wheel types. And if we did it again, we might try for 3 types of wheels on each pass. But anyway, it did give us a chance to test out the different, closing wheels. We counted out the seeds so that we would be able to get a % emergence. We could go back later and count how many came up. And then the field had a couple different soil types. I think Joe's got a picture of those on the next slide, and he can kind of explain how we arranged those.
Yeah, so we just tried to, you can get a fair idea of the soil types that you might have in your field based on the topography of that field as well. So in the bottom center of this frame here, you can see that Martinsville silt loam soil. That's an eroded hill slope, and going down to that sort of crescent shape there of the Rensselaer clay loams. So you go downhill into the kind of lower ground, you get a little bit darker and a little bit heavier soils. Those are clay loams. So the idea is you just want to mix up and get a representative area of your field based on your soil types and what you have out there.
So the first the data that we took was to count emergence. That's basically what we were going to do, and we didn't do that until 3 weeks after because it was quite dry at planting, and so things weren't really coming up. And we just counted how many seeds came up in each row, in each test row. And at that time, we could already see that there was some variation emergence. Some seeds were still coming up, even not as far up as that, and some already had, a few true leaves. We also saw some seeds on the surface that had been eaten, which is a problem that had been happening in that field.
And then we came back a couple of weeks after that because it had been so dry, to see what had continued coming up. And this is a picture from is that plot 1 that was on the bottom right corner of the field, and this is looking up that hill slope, and you can see here the emergence was not very good. We seemed to, during planting, it seemed that one of those closing wheel types was doing a much better job visually while we were out there. It was doing a lot of what we would expect after that planter had gone through the field. But that's why it's important to collect data when you're doing these sorts of things, and then see what that data tells you, because you can't always believe your eyes.
Yeah, basically, like Joe was saying, we thought we were going to see a big difference in the closing wheels, but on this graph, you can probably tell. I mean, each color is a different closing wheel, and with the amount of variation we had, this is like the least to the most for those. Sometimes a closing wheel might have done really poorly, sometimes really well, and when we averaged it out, we really couldn't say one was better than the other. And so we were thinking, well, gosh, maybe, what else is a factor here? Maybe there's another confounding factor. And we got back to looking what we saw in the field at that time.
Right, and obviously we were a little disappointed by that graph because we were hoping for some more clear-cut results than that, as you always do when you do a trial like this. But we, in true fashion, you just don't always get that. So we started trying to talk through what else could have happened and what might have happened. And on that bottom right picture, you can see that furrow cut through the field, but you can't see any evidence that the rest of that planter unit has run through there, right? You don't see any disturbed soil on that. All you're seeing is that fertilizer coulter that you can see in that middle picture at the top of the screen there. That's that silver disc up front on that planter. Yeah. That picture on the left is a little bit more what we would expect. You can see that disturbed soil where that planter has run through, opened it up, dropped the seed in, and those closing wheels are doing what looked to be a good job of fracturing that soil back over to close that seed slot. And then as we walked the field then, after, mostly it was because Liz and I got talking and they got ahead of us planting, so then we had to catch up. But Liz's eagle eyes then also saw this that you're seeing here in the pictures, where you can actually see a seed exposed here. So even though that planter went through the field and it looks like those closing wheels did a good job closing up that furrow, that seed is still exposed. So that sort of led us to thinking a little more about those confounding factors that Liz had mentioned, and what else might have been going on here. And then Liz, you then mentioned that you were seeing some strange things in some of your fields, right?
Yeah. After seeing that there, I had some no-till sweet corn pumpkin trials at Penny, and here we're moving, these pictures here are of sweet corn, but I had planted into rye with the sweet corn, some planting before we rolled it and some after we rolled it. And I had worse emergence in those plots where the rye was rolled compared to the bare ground plots. And when I had looked at them closely in the field, on the lower left of this, I don't know if you can tell, but that there's supposed to be a furrow there to plant a sweet corn seed into, and it just wasn't very deep at all. And I could actually see some seeds, practically still see them on the surface of the ground when I was looking at those, when I went to count emergence in my trial. So I thought, well, maybe this is the same kind of thing. And I don't know, Joe, you've got a lot of experience with this stuff. I don't know how common it is, but we were trying to think, how can we fix this so that we can get things planted right next year?
Right. So I'm a cover crop agronomist, and I work a lot in no-till and soil health systems, and it's a common thing that we see across the board, regardless of crops, is just that you have to be diligent about setting up your planter to plant into these, because it's a very different planting environment. If you're used to conventional tillage and loose soil, when you move into no-till, when you move into reduced tillage and cover crops with a lot of heavy residues, there's just a lot more there. There's a lot more mass there that you have to cut through. So then in talking, we were like, well, maybe we need more weight on these planters. And Liz said, well, I have some extra space in my fields. Let's try that. So you can see in these pictures here that we have, a very high-tech way of adding weight to the planters in just putting sandbags on the row units. There's, of course, a lot of different ways you can add weight to the planter or increase downforce, but we just went with sandbags. You can see in the bottom right picture, there's some cover crop residue from the previous spring. We did these in the fall. You can see the orange pumpkins there, but then there's also some volunteer rye coming up in there. So, sort of simulating a little bit of a planting green situation. And Liz, can you walk us through how we set that up?
Yeah, again, this was pretty simple. We had 4 planter passes. That's what's labeled 1, 2, 3, and 4 on this slide. And then we have a 4-row planter. So on each row, we had a different amount of weight, and we switched which row had which amount of weight on each pass. And since we were using these 70-pound sandbags, we had either 0 or 70 pounds or 2 bags at 140 or 3 bags at 210. And let's see, what else can I say? Our planting strips were 50 feet because that's kind of how we had the field set up. Yeah.
If you want to try something like this, what you want to look for is you want to drop the planter in the ground and run it for a little distance to make sure everything's in the ground and working like it should. And we have a little video here, if it plays, of what you want to do. So you just want to drop that planter in the ground and run it, and then stop it and make sure they're clear of the controls. Walk up and see if you can spin that gauge wheel. If you can spin that gauge wheel, if it's freely spinning like it is here, that's bad, right? Because if the goal is for a consistent planting depth throughout the field, your gauge wheel is how you get that consistent planting depth. And if you can spin it that freely, it's not touching the ground. So you have no real idea of what depth you're planting at, and you're definitely not getting a consistent depth. So that led us again to, okay, we do think we need more weight on the planter now. So what does that look like? You know, like we said earlier, you can't necessarily trust your eyes. So you have to do some measurements. And we checked right behind the planter. We dug up some seeds, and the pictures on the left, these are paired pictures. So the top and bottom on the left pictures, you can see where that furrow was barely cut. You can see those seeds basically laying on the ground. They, you know, some of them were maybe 1/4 of an inch deep. The pictures on the right, you can see, are quite a bit deeper into the ground, right? So you can see that cut furrow. You can see where we were able to open that soil up, cut through the roots, cut through the residues, and get that seed down into the ground. And that's a little more what you want, but again, you can't trust your eyes, right? So you have to take a look at the data.
Yeah, so we went back, this was in the fall, you know, a week and a half after seeding, and counted how many seeds came up. And basically that blue bar on the left is no extra weight, and fewer seeds came up by that time. Then no matter, you know, we put any weight on, we got better emergence. So that was the real take home message from this. We definitely needed some weight. But you know, if you remember that video that Joe showed, so when we were checking the gauge wheel, we checked 0, that spun easily. 70, even the 70-pound one, I think spun a little bit, right? And maybe even the 140-pound one. So we're thinking probably for the conditions that we were at, we probably needed 140 or 210 pounds to get it into the ground evenly all the way through.
Yeah, and it was pretty wet. It was probably much wetter than you would want to plant.
Yes.
But for the interest of the trial and the days that we had available, it went, you know, we know we need more weight. That's something you might want to just have to dial in a little easier or a little better at your planting conditions and at the time of planting. And then of course, the farm crew already thought we were probably a little bit nuts. And they were very gracious to help us out and reserve most of their judgment. But then, you know, we dug up some more seeds, and what you're seeing here is the depths that we were able to get with some of those, and with just whatever setting the planter was at. You know, with 0 weight on that planter, we were at very shallow, maybe 1/2 inch of depth there. And then, you know, moving down to that bottom right picture, you're at 2 inches, right? So that's with the full amount of weight we had, and that's probably really close to what the planter was set at. Although because that gauge wheel didn't spin at all at that depth, or at that weight, that might be too much weight. You might be at risk of causing some sidewall compaction with that much downforce. But you know, that's just something that needs to be dialed in a little closer.
Yeah, and I would just say on that, I mean, that showed like 2 inches deep. 2 inches is deeper than I would want to plant sweet corn. I would go for something, you know, more 3/4 to 1 1/4, depending on the soil conditions. But
Right.
that was right. There's a question that kind of goes right to that almost, Joe, in the chat. It says, would increasing planting depth also work?
No. So increasing the depth on your planter without being able to achieve that depth won't necessarily help you. So when you increase your soil structure and when you have residues that are going to be on the surface of the soil and especially in cover crops with the roots in the soil, it just takes more resistance. There's more resistance to getting that planter unit in the ground. So if you can't get that, that's why you want to spin that gauge wheel, because if that gauge wheel is not touching the ground, then you just don't have enough weight on it.
Yeah.
So increasing the depth then won't get that gauge wheel on the ground, really.
Yeah. I mean, it might bounce around, you know, that planter units kind of might be bouncing along, and sometimes it might get in deep, and that's great, but other times it might not be able to. And I think that's what I saw in you know, when I did my Maine sweet corn trial. But
yeah, absolutely.
Yeah.
And this is stuff we spend whole planter clinic days on, and we didn't even scratch the surface here in 20 minutes.
Right. No pun
or
intended.
a little over, I guess. Yeah, but you know, the point of all of this is just that, especially if you guys are going to be doing cover crops and reducing tillage, and I would encourage you all to, as great ways to help increase your soil health that we'll talk about here in a couple of weeks, and I hope you join us for that. But it's just important to remember that that's a much different planting environment than what you may be used to, and your equipment may not be set up for it either. So you have to take a look at how your equipment is set up and make sure that it's doing what you need it to be doing and what you think it's doing. And Liz, I think you had a couple of closing remarks there too.
Yeah, I think I was going to say that if you know, setting up these trials on your farm is pretty simple, and if it's something that you would like help with in terms of setting it up and maybe figuring out how to collect data, Joe and I'd be happy to help with that. As long as it's not 500 of you wanting to do it. But anyway, but if you're interested with that, you know, contact your county educator, and I'm sure they'll know how to get in touch with us. And I wanted to give a little plug. These sweet corn pumpkin trials I did at Penny, I am just getting ready to put some YouTube videos about those trials online, so you can learn all you ever wanted to learn about those. If you wanted to learn more about those, there will be some videos up pretty soon. You can check the Vegetable Crops Hotline, and I'll let you know where those are. I think that's. Did I remember everything, Joe?
I think so. Although I'll get out of this, and I had to close the chat. So if there's any good questions in the chat, and if
there
we have
are
time.
A couple, but we're already going into the next presentation. So if it's okay with you two,
Yep.
we will send those questions to you, so then we can email back out to participants.
That's absolutely fine. Thank you. Thanks, everybody.
Thanks a lot.
Thank you both. And so next we have Dr. Stephen Meyers, who will be sharing a weed management update.
All right, Rebecca, can you hear me?
Yes.
All right, fantastic. Okay, it's good to be with you. For those who don't know me, I'm Steve Meyers. I'm a weed scientist in the Department of Horticulture and Landscape Architecture at Purdue. And I've got Janine Arana and Brandy Woolham, my grad students, on this title slide here as well, because let's be honest, they did most of the work. So at the end, they can help answer some questions maybe with us. So we're going to talk about some of the frequently asked questions I got in 2020 from growers. We'll touch on some of the research that we did in cucurbits in 2020. I had planned on also having a looking forward to 2021 section, but I don't have enough time for that. So we're going to just go with these kind of objectives here. So with frequently asked questions in 2020, so one of the questions that I got was related to grass herbicide injury on cantaloupe. And this is something I've seen before in my own use of graminicides on my little garden patch at the house. And what you notice is some of the growth will turn chlorotic or yellow. So you can see that in the photographs on the screen. You also get some necrosis around the leaf margins and sometimes into some of the major vein areas of the leaf as well. And for the most part, the crop grows out of it pretty quickly. Except, you know, we were hearing about really severe injury to cantaloupe in the southern part of the state. And so we did some greenhouse work, used the maximum rate of select that we could, which would be the 16-ounce rate and then we included different amounts of surfactant all the way up to a 1% by volume, and trying to get some severe burning injury from those treatments. And we couldn't really get or replicate what the growers were describing to us. This is the most injury we were able to get out of our highest rate of select with the highest rate of surfactant. So again, we see those same symptoms, a little bit of leaf distortion here, but necrosis along the leaf margin, and then some necrotic or dead plant tissue at the tip of the vine as well. Another question that, so kind of moving along those same lines, I guess, with grass selective herbicides, as far as general recommendations, consult the label is one. The label may specify what kind of adjuvant to use, whether it's a surfactant or a crop oil, based on the crop that you plan to apply it to. The other thing is to think about the amount of those adjuvants that you use. So I know some of the surfactant labels will tell you can go up to a % by volume, but I really see not a ton of advantage of going greater than 1/4%. So that would put you at 1 quart of surfactant per 100 gallons of spray solution. And you can kind of round that down if you've got a smaller tank that you work with. Crop oil would be applied at a 1% by volume basis. So that would be 1 gallon of crop oil to 100 gallons of spray solution. Both of these should be applied to non-stressed crops and small actively growing grass. Small grass can be killed more easily, and it requires a lower rate of these products, so that's fantastic. If the crop is under stress, you probably have better luck with a surfactant. Surfactant helps to decrease the surface tension along the leaf, increase the surface area of the droplet of herbicide on the leaf of the grass, whereas a crop oil actually starts to kind of eat away at the waxy cuticle on the leaf of the plants. And so we tend to see less injury from surfactants for that reason than with crop oils. Another thing to do is avoid applying on hot, humid days if you can. And if you can't, try to apply at a time during the day that's not the hottest or most humid part of the day to try to avoid some crop injury there. One of the other things is to be mindful of pre-harvest interval. So with Select, which is clethodim, for all the cucurbits, you're looking at a 14-day pre-harvest interval. So from the time you make the application to when you can harvest the crop, 14 days. So if you are less than 14 days out, you might look at post, because it's 14 days for all cucurbits with the exception of cantaloupe and cucumber, which is 3 days. So if you're going to be picking cucumbers in 5 days and you want to kill some grass or at least get it started, you've got post and you can't use Select. The other thing is to be patient. These are systemic herbicides, so they move throughout the grass before they effectively kill it. So this is, again, is from the garden patch at my house that received an application of clethodim, a generic version of Select, actually. So you can see on the left photo there, a clump of grass that looks pretty healthy. This is probably maybe 5 days after application. So if you're not certain if your grass herbicide is working, what you can do is walk up to that patch of grass and find one of the individual growths and find the center of that whorl and just kind of pull up gently. And what you should see, if it's been, let's say 3 to 5 days, you might just see some water soaking, some soft tissue at this point. But kind of 5 to 7 days, you should start to see some necrosis or dead plant tissue right there. And that's just the herbicide working at the growing point of the plant. So this is one way to kind of confirm that it's actually doing what it's supposed to be doing, even if you don't really see any visual symptoms. Okay, so another question we got was for pumpkins about, can I apply Sandia, which is halosulfuron, and Select Max together. So Sandia works well on a lot of our broadleaf weeds, but not on grass. And Select Max is a grass herbicide. So it's logical that folks would want to combine them to try to control both broadleaves and grasses. And the answer is yes, you can do that, but there's been limited research on it. So really there's been one study that was done in Southern Illinois that looked at this. And what they found was that you have reduced grass control when you apply both together than if you were to apply clethodim by itself. So you probably get a 5 to 10% reduction in grass control when you apply the tank mix compared to just applying the grass herbicide. They also saw an increase in crop injury. So that's another thing to be aware of. Now, just because you tank mix the two together doesn't mean there's a new set of rules. You have to follow the rules for each individual product, which means we're applying to small susceptible weeds. Again, that's partly so we can keep the rate low to try to reduce the risk of phytotoxicity or damage to the crop. We also need to be mindful of things like the restrictions of plant size or plant development for Sandia, which is between that 3 and 5 leaf stage to the first female flowering stage of growth. So we got to target that window if you're going to use the tank mix as well. And then also try to apply to non-stressed crops and weeds, because these are both systemic and they move through healthy weeds better than they do sick weeds. So another question we got is about dual magnum, and can it be applied within a pumpkin row? And the answer to this question is a really scientific one, that it depends on your state. And the reason for this is because there's a lot of 24C special local needs labels for dual magnum. And if you just have the section 3, the national label, this is what you'll see. It says inter-row or Interhill Applications, right? So if you are in a state, most of you are from Indiana. Indiana has a 24C label for dual magnum. It can be applied in the state of Indiana, and possibly your state if you have this label, as a broadcast spray over the planted row or hill. So now whether you can do it or can't do it depends on which state you're in and which label you have. The other thing to be mindful of is that a lot of the products that are generic metolachlor, for example, I use one that's called Me Too Lachlor, don't have pumpkin on the label. So if you have a generic metolachlor as opposed to an S-metolachlor product, you may not be able to spray it legally because the crop doesn't appear on that product label. The other thing, we have seen some injury from dual magnum applications, and we'll show you what that looks like. It's not, at least in our experience, been severe or had an impact on production, but we'll just show you what those symptoms look like here in a second. And the other thing you want to do is make sure you apply it to a weed-free soil surface, because this particular herbicide does not have any post-emergence activity. So if you apply it to weeds that are emerged, you won't control them. This is what the injury looks like. It's essentially just kind of a little bit of leaf drawstring or leaf distortion. You can see that on the first true leaf that emerged. The second true leaf looks fine. All the subsequent other leaves look fine as well. We had a grower that I talked to this summer when he was trying to decide on whether or not to use dual in the row. And this is what his experience was. He applied dual in the row middles at 1.3 pints. And I guess I should say that one of the predominant and worst weeds in this field was yellow nutsedge. And dual is really one of the only products, aside from maybe Sandia, that provides some amount of nutsedge control for us in specialty crops. And so you can see he got good control in the row middles where he didn't apply dual within the row. He had a lot of escaped nutsedge. And so one thing to be mindful of is the weed spectrum within your field. For example, if you had nutsedge, you would, if you had the right label, want to go ahead and spray over the top of the row too, so you could control the weeds within the row. Okay, so the other question I got is related to plant back restrictions or herbicide carryover. And the question is, how accurate are the plant back restrictions on various different residual herbicide labels? And sometimes they're very accurate and sometimes they're not. And there's a lot of variability that goes into how persistent a herbicide is in the soil. Some of our herbicides will infiltrate into the ground. Some will become volatile and come off the soil surface. But for the most part, they're degraded by sunlight or by microbes in the soil. And so for a lot of them that are degraded by microbes, how quickly that happens depends on conditions in the soil, soil moisture, soil temperature, pH, organic matter, those kinds of things. Most often the label is going to be really conservative. And so it'll probably overestimate the amount of time required before you can plant back. But the important thing to remember is that the label's the law. So if you contact me and say, hey, this was sprayed 12 months ago, is it fine to plant pumpkins, watermelon, tomato into this field? I can tell you what the literature says, but at the end of the day, if you don't follow the label, that's on you, I guess. We're going to share a little bit of the research trial results. We got about half of the research that we had planned for in the ground in 2020. And one of those was a morning glory study. This is part of Janine Arana's graduate work. And the two photos on the left are actually from Dan Egel, who spoke earlier in this webinar. And from what we hear from our cucurbit growers, morning glory is one of the most problematic weeds. And it's that way for a lot of reasons, but one is because how do you disentangle a vine from a vine crop? It's very difficult. And the other is related to what you see on the right photo of the screen there. If you look at this morning glory plant, I was pulling up morning glories at our Meg's research farm in Lafayette, Indiana, and you can see this white part of the hypocotyl, so the part below the cotyledons. This morning glory emerged from about 3 inches deep in the soil. And when we apply residual herbicides or soil applied herbicides, and we get them activated with a rainfall or irrigation, we're mostly trying to control weeds in that top inch or so of soil. And if you have a weed like this one that's got a big seed and it can grow from 3 inches deep, it's hard to do much about that with herbicides. So we did a study looking at the effect of morning glory interference in triploid watermelon, utilizing fascination watermelon, had 3 rows, 6 feet apart, put 4 triploid melons in each of those rows, and then pollinizers as well. And then we had 6 morning glory densities, so 0 per plot, 3, 6, 12, 18, and 24 per plot. And we planted morning glory plugs into the same hole as our watermelon plugs. And this was done at 2 locations, so one in Lafayette and one in Vincennes. Just a shot of what this looks like. At certain times during the season, we would come to these fields, we'd measure vines, we'd do other things, but one of the things that we did was we tried to take a visual estimate of the makeup of the canopy. So what percentage of the canopy, the vegetation, had morning glory on the top or the uppermost part of the canopy. And so that's what this data right here is going to be. So these are our 2 locations, Meigs, which is Lafayette, Southwest Pack, which is Vincennes, the different morning glory densities on the bottom here. And this is the amount of, essentially the amount of green vegetation that was occupied by morning glory on the top of the canopy. And you can see that for the most part, we just, of course, we increase, we level out here at about our 18 per plot number. But essentially those morning glory are growing on top of the watermelon and shading them out. So we also took, and by we, of course, I mean Janine and Brandy, took a 1 square meter of each plot, harvested all the green material, and separated it out into watermelon components and morning glory components. And you can see for one of the plots, this is what it looked like. That would be the morning glory component, and then what's left is the watermelon. And so, of course, what you might expect was that at our weed free, we had a lot of, well, watermelon dry weight in that 1 square meter. And then when we introduced any amount of morning glory, the dry weight or the dry matter of the watermelon plant itself just dropped off completely. And so that was reflected in yield as well. This is yield in kilograms per plot at the 2 locations, so the Lafayette location and the Vincennes location. And you can see what it does to yield, right? So even at just 3 per plot, or 1 morning glory for every 4 watermelon plants, you can see we see a significant reduction in watermelon yield on a weight basis. And we see the same thing if you look at it on a fruit number per plot basis as well. All right, we'll move on to Reflex. So Reflex is famestophan herbicide. It's a PPO inhibitor, so it's similar to Chateau or Valor if you've used that product before. It has a 24C registration in other Midwestern states. For example, watermelon in Missouri, pumpkin and winter squash in Illinois, Michigan, Minnesota, and then summer squash and pepper in Michigan and Minnesota as well. And one of the things talking to our Indiana producers, especially those that grow along state borders, so they'd like to have the same herbicides available to them that growers in adjacent states do. So what we're doing with these studies is trying to get local data that support a label for the state of Indiana. So we did this in a lot of different crops. You can see pumpkin, for example. For a lot of these crops, we had more than one variety. Pumpkin, we used Bayhorse and Carbonado Gold. Summer squash, which we won't talk about today. Watermelon utilized Fascination and Exclamation. And we had several different rates. So our check would be 0, herbicide applied. And the 1X rates that we used depended on the crop. So for watermelon, we'd have a 1X rate that would be 12 ounces to the acre, and then all the way up to a 4X rate, which of course we wouldn't apply in a field setting. But for us, we need to know at what point our crop safety breaks and we can actually injure the crop. So similarly for the summer squash, the pumpkin, winter squash study, the 1X was 16 ounces, and then we went all the way up to 64 just to see where we can make it break. Looking at the pumpkin data, we'll show you what this looks like. So on the left chart, we have emergence. So with our non-treated, we've got greater than 90% of our pumpkin plants emerged. And you can see with 1X rate, which would be at 16 ounce rate, or 2X rate, we drop off. And then we see another significant drop off here with our 3 and 4X rates. Now, if we look at weed control at 4 weeks, this wasn't necessarily a weed control study, but we did rate for weed control before removing all the weeds by hand. So we can see what weed control looked like here. Pretty good control across the board, but for the most part, as we increase in rate, we get an increase in grass and broadleaf control. Now this whole study got dual magnum, just a blanket application to help us suppress weeds. And then it also got the reflex rates that were part of the study. So you can see what this looks like as far as the emergence goes and the weed control. This would be our check of Bayhorse, our check of Carbonado. And then the 1X here, you can see we get some, control most of our weeds with that 1X rate, but we're starting to see a reduction in plant stand. 2X rate, again, clean field, but reduced stand. And of course, that is just more severe as we get to the 3X rate and the 4X rate, where there's virtually no pumpkin plants in the 4X. So moving on to yield, if we look at the left figure here, we got separated by variety. So Bayhorse is on the left and Carbonado is on the right. Fruit number per plot. So if you're looking at fruit number here, with the non-treated, we see a little drop off maybe with the 1X, but for the most part, not anything that's going to be significant. So that's good. The same thing for Carbonado, not really much difference between the non-treated and the 1X. So that's a good sign for us. Now that's total pumpkin fruit number. If we look at just marketable, which would be the fruit that are a certain size, greater than a certain size based on what the variety is supposed to be, and then orange in color, we do see there might be a little bit reduction between the non-treated and the 1X, both for Bayhorse here and Carbonado, but for the most part, really similar to the non-treated, which is good. Now that was fruit number. If you look at weight, total weight per plot, really no reduction between the 0 and the 1X rate. We did see a difference in varieties. I know on the commercial break there, you saw Rupp advertising Bayhorse Gold, and for us, it did out yield Carbonado Gold quite significantly. And you can see that on the screen here. We had the same treatment set up in bare ground on winter squash as well. And I'll just show you what some of that data looks like. This would be injury at 2 weeks after planting. The non-treated, based on this model, is 5% injury. In theory, it would be 0. And we increased all the way up to 48% at a 4X rate, which is not surprising. And you can see what the injury looks like at that 4X rate, some kind of necrosis and kind of whitening of the first set of true leaves there on the pumpkin plant or the squash plant. However, even though we saw injury at 2 weeks, it didn't really affect yield. So we combining the yield rather from the 2 different winter squashes that we grew, which was a butternut and then an acorn variety. We didn't really see much reduction even at 3X. You had to get to this 4X rate before we saw a drop off in yield. So that tells us that we have good crop tolerance to reflex in these winter squashes. This is just pointing out the yield data there. Okay, we also had it in reflex. So in this case, we applied, broadcast applied across the top of the bed and in the row middle. and then planted into it after that. You can see some of the injury that we had on some of the older growth. We see what we call bronzing, so this kind of brownish bronzing symptomology. However, for the most part, the new growth didn't have symptoms, and it grew out of this injury symptom. So this is a lot going on here, to be honest with you. So we got the 2 different locations. So this would be Meigs, Lafayette. This would be Southwest Purdue Ag Center in Vincennes. And essentially what you can see is that as we increase rate, we increase injury. So not a ton of injury. We top out around 20%. 0 would be no crop injury. 100% would be complete crop death. So even though we're stair-stepping up with rate, we're still not seeing a ton of injury from these treatments. Now this would be yield in fruit number, and then also in kilograms per plot. So fruit number per plot, the 0 here, this is Meigs, the Lafayette location. So this would be our non-treated and our 1X rate right here. So we're right there. We're not seeing a reduction in yield. If anything, we're seeing a little bump in yield as far as fruit number goes, and also for fruit weight. At the Southwest Indiana location in Vincennes, really no differences across the board. So everything here is pretty similar to the non-treated check as far as fruit number and fruit weight per plot. All right, so with all that, what we conclude across all those reflex studies is that our 1X rate of reflex was really resulted in pretty minimal injury at 2 weeks after, and that injury was not persistent and didn't seem to reduce the yield of any of the crops that we grew. It's not, like I said, it's not labeled Indiana. If you're in another state where you have reflex, you can go ahead and implement some of what you've seen today. For the folks in Indiana, we're going to try to get these studies out again in 2021. That'll give us 2 years of data and several locations that we can then take to Syngenta and try to get a 24C label for our growers to use this product in the state of Indiana. Let's see, my next slide will be my contact information if you want to reach out to me. I think I'm afraid to stop sharing because then you won't have that information, but I can also drop it in the chat. So I'll stop sharing now and take any questions that you might have.
So I don't see any questions currently in the chat, but everyone please feel free to type any questions you have for Dr. Meyers in the chat. We do still have a few minutes.
We went way over when I practiced. I don't know how. Time for questions now. So.
It's a quiet group today. I guess the other option would be to keep going the next presentation. What do the other moderators think?
Becca, there was a poll question, I think.
Yes.
From Meyers.
Yeah, there may be 1 or 2. Yeah, that's right.
Yeah, there was a pre and a post. Apologies, we didn't do the pre. Did you still want to do the post?
Sure, yeah.
Okay. So if everyone can take a moment to answer the question you see on your screen. It's kind of slowing down. We'll share results. So it looks like most people said chemical herbicides.
Sounds good. Thank you.
Okay. If we don't have any further questions, thank you, Dr. Meyers, and we will have Dr. Laura Ingwell and Dr. Elizabeth Long sharing with us integrated pest management and considerations to pollinator-dependent crops.
Thank you, Rebecca. So I was all flustered at the beginning and didn't even really introduce myself. So sorry about that. But I am, like Becca said, Dr. Ingwell. I work in the entomology department on specialty crop pest management. And my colleague is here with me. I'll let her do a quick intro while I get this going. Elizabeth? Sorry, one second.
Sorry, Laura. She's added as a co-host now, so she should be able to speak.
Okay.
Oh, there. Sorry about that. I was just
Sorry.
talking and didn't even realize I was muted. I'm sorry. I'll just briefly introduce myself and say that, as Laura mentioned, I'm her colleague also in the Department of Entomology. Excited to be with you all today and talk a little bit about, IPM and managing pollinators and your pests in these specialty crops. So I hope
Sorry,
you can all...
the transition's slow. I'm working on it, Elizabeth.
No problem.
Maybe. There it goes.
Okay, so we have this outline that we're going to move through pretty quickly. Really what we're hoping to share with you all today is just talk briefly about the importance of pollinators for specialty crops. I'm sure you all know that because you grow specialty crops, so we won't spend much time. We're going to focus most on risks to pollinators in specialty crop systems, emphasizing, pesticides and which ones are most harmful, how might they be exposed, and then wrap up with the what can you do part of this talk. And we'll focus on an IPM-based approach for managing pests, but also pollinators. So as you all know, and I'm going to go through this quickly, pollinators they're crucial for many agricultural systems, but particularly specialty crops. And I just have a table here that I pulled online of some of the key crops, many of which you all may be growing. And I have a key list of the pollinators here: honeybees, squash bees, bumblebees, and solitary bees. We have a few pictures of these on the next slide. I have this ranking here for pollinator impact, pulled from some resources, and 4 being essential. So you will not get fruit set without pollination by insects in these crops. So just a little plug here about how hard these bees are working. 5 to 1,000 grains of pollen are required for effective fertilization of watermelon. And if you shake that out, that could be anywhere from 10 to 20 visits per flower for fruit set. So in a nutshell, of course, the more pollinators you have visiting your flowers, the better your fertilization and thus your fruit set will be. So there are many important insect pollinators. I don't want to downplay, or we don't want to downplay other important insect players, but the bees are a key group that you're certainly all familiar with and that we'll talk a bit more about because there has been a lot of attention focused on them. And so these are just some pictures of those same groups of bees that I mentioned on the earlier slide. So anywhere from honeybees all the way to the solitary bees. So why all the buzz about bees? We wanted to mention this briefly for those of you who don't know, but pollinators are experiencing global declines, and we're hearing more and more from beekeepers that they're losing more and more after the winter season than ever historically seen before. And we now have our first endangered species, bee species in the United States, the rusty-patched bumblebee, sadly. And so there's a lot of interacting factors that we know from research at Purdue, but also globally from other institutions, that there's really an interaction between multiple factors, or what you may also hear us say are stressors that are really having a negative impact on the bees. And some of those are listed here, or the ones I would say there's most consensus about: the loss of habitat, and of course land use change, climate change, pathogens, and parasites. And in this case, varroa mites actually do transmit some pathogens to bees. And the last one I have bolded there because we'll spend the most time talking about it, increasing risks of exposure to pesticides in these specialty crop landscapes. So many people ask, which pesticides are most toxic and how can I think about using these pesticides, relationships between them to manage pests, but also keeping in mind pollinator safety. And so tried to shake that out in a simple slide here. Sorry for all the words, but in general, herbicides are the least toxic, fungicides in the middle, and then of course insecticides being the most toxic, right? Because insecticides kill insects and bees are insects. I do want to mention though, herbicides are bad for bees because they destroy flowers and particularly weedy plants that bees are often using and visiting for pollen, particularly during the season before our crops are blooming. So 3 key points I want to leave with you on this slide. One, when you think about these insecticides in particular, consider how they work and how long they stick around. And I think an easy example we're all familiar with are the contact insecticides that are fast action. And these are the ones like in the can, you spray the wasps, you spray the nest, and those wasps fall to the ground immediately. Those chemicals are very fast acting. They knock them out and they're gone pretty quickly because that's what you want in the case of wasps. But on the other hand, there are also these insecticides that are ingested and they take a little bit longer to have their effect, and they may have longer residual activity. So keep in mind when you're thinking about an insecticide to use in your system and the pest you want to manage, consider how they act, right? Is it something that, like I mentioned, you can just spray and it's gone pretty quickly, or something you can put out that's going to stick around for a long time? And of course, the longer it's around, the more likely it is for a beneficial insect like a pollinator to be exposed. And you've all likely heard of these neonicotinoids, also called neonics. They've gotten a lot of attention in the media because we know that pollinators are especially sensitive to this class of insecticides, and they're exposed in a lot of different ways that Laura will mention later in the talk. The other 2 points I'll mention that are a little bit shorter, there's also, we're learning more and more that there are these synergistic, or what you can also think of as potent mixtures that exist between certain fungicides and insecticides. So for example, when they're tank mixed or applied close behind each other, they become more toxic when combined than when they're alone. And also certain adjuvants, and these may be called wetter, stickers, or spreaders, they can also be toxic for pollinators too, so keep that in mind. Moving on then, which pesticides are kind of more toxic or most toxic to pollinators. How are they coming into contact with these pesticides? And I think in a nutshell, it's in all the ways you can probably think of and more. So obviously these bees, they're out flying around in the environment, landing on things. They may come into contact with these pesticides directly, right? They may be flying in the path of sprayers or flying behind planters. We've done a lot of work at Purdue and understand that pretty well. Their body hairs, as they fly through the air, they actually become static charged. And so they actually attract these tiny particles to their bodies. And of course, collecting pollen for a living, they're specialists, right, at attracting these tiny particles to their body. Their living depends on it. So something to keep in mind in terms of direct contact with pesticide residues. They can also be exposed indirectly, or what we think of as secondarily, by contacting treated plants or soil or water. So you can see a little bee here moving down to take a drink from a puddle. That is a way that they can be exposed to pesticides if they're moved into water or puddle up out in the landscape. But also through ingestion of contaminated pollen nectar, and of course landing on surfaces that may have been recently sprayed. Okay, I'm going to turn it over to Laura.
Sorry. So as Elizabeth was describing, if we really want to think about conserving pollinators in our specialty crops, which is what we're focusing on here, because we rely on that pollination service for them to produce the product we're trying to sell, we really need to approach their protection from a whole system thinking. So that means, in my mind, moving beyond that specialty crop that you're growing, but understand the foraging radius of the bee and all of the different ways that bees interact with the environment to be able to acquire the nutrition that they need and reproduce successfully. And so one of the examples that we're going to be drawing on today is probably not a surprise to most of you, because we've been spending quite a few years working in this particular system, mostly because it's a really important specialty crop in the state. So a lot of the examples here that I'm drawing from come from watermelon and cucumbers, two cucurbit cropping systems that we've spent a lot of time collecting some really minute details about bee activity within this crop and in the environment in which these crops are grown. And so what I'm showing you here is across one season, what the pollen resources look like for honeybees that are placed in a cucumber field. So growing in a commercial cucumber field, this is in southern Michigan. We can actually put these little traps on the front of the hives and scrape off all of the pollen that the worker honeybees are bringing back into the hive to feed their family. And so the focus here is on that cucumber crop, right? This farmer is paying to have these honeybees in his cucumber field to pollinate that crop. But what you actually see here is that early in the season, when those bees go out into the field, the first thing they're foraging on is sumac, which is present in the environment. Then they switch to corn, which is the next most abundant resource. And lastly, when it gets towards the end of the season and they're getting ready to overwinter, they're foraging on goldenrod. The actual crop is less than 1 to 2% of their diet. So cucumber pollen is not the most essential protein that they're foraging for, but they also are known to be feeding on the nectar. So if we want to think about exposure routes for these bees, we have to consider where those chemicals are coming from. And maybe, I would argue, take a little bit of the focus off of that specialty crop. So what I just laid on top of this, and I hope it doesn't get too messy for you, is an analysis of that pollen that we collected off of those hives, looking at the residue specifically of neonicotinoids or the neonic insecticides. But I do believe all of the insecticides are present here that we could detect with the tools. And so what you can see here is a short little peek at the beginning of the season. The colors don't really mean anything, but if you look at this bar graph, you see really high levels in this last red bar. And this is down in August when they're foraging on corn and switching that forage over to goldenrod. And so what we show here is that there's really no link to cucumber bloom in terms of the pollen resources that they're collecting. And there's no link in a spike of pesticide exposure during that short window, which is right here under this flower when cucumber is blooming. But where we are seeing this spike in exposure is when they're foraging on corn and goldenrod. And at that time, as little as 1 gram of pollen from these traps contained a lethal dose of that insecticide. So when we talk about these different tools, I want you to be able to put that into the context of beyond your specialty crop, but for those of you that also grow field crops, how you use some of these tools in that situation and what the implications are for how the chemicals in particular that you use may be moving across the landscape. But really, if we want to take this back to the ultimate goal here is we need to be able to manage the insect pests so that we don't lose our yield, but also promote pollination so that we get the fruit to sell. So we have to be able to balance and manage these two things. And we have a variety of different tools that we can use to do this. So the first one we broadly call cultural controls. Then we have pest monitoring tools. And then lastly, in this framework of IPM is we turn to pesticides. And so there's a variety of different ways and different types of pesticides that we can apply. And so I'm going to walk through all of these different tools. So in terms of, oh, this one's for you, Elizabeth. Sorry, go ahead.
No problem. Okay, so just talking about cultural controls, then these are things that you can do, or your actions you can take to reduce pest damage. And so One example that I think is pretty intuitive when I think about cultural controls are to time your planting, or in many cases delay planting, to avoid the damaging life stage of a particular pest, or delay planting, for example, to avoid a favorable condition or time of year for the pests. I also included exclusion netting here, or row covers. Obviously, those aren't an option for people at large scales, but they can be very, very helpful. And of course, then growing resistant varieties, because these are varieties that can tolerate or handle damage by insects without any loss to yield. Another important tool is pest monitoring. And so many of you probably know about these as baited or lured traps. These baits are often a food item, or some synthetic odor of a food item or a female. It lures them into the trap, and you can use that trap to kind of keep track of how abundant or peaks in the activity or abundance of the pest in the trap, and that kind of becomes a signal to you, oh, they're starting to show up in these traps in high numbers, it's time for me to take action. And along the same lines, you can also do scouting. So going out and looking, for example, in your watermelons for a certain number of beetles that you know are economically damaging. And I just have some examples here of fruit, not melons, but spotted wing Drosophila, which is one that many of you likely know about. It's a big problem in many small fruits. And so there's several really nice traps that are very effective for detecting the adult, which is this little fly here with the spots on its wings. And folks are using this trap to keep track of how many adults are there, so that they can avoid a case where they can monitor and take action and avoid this scenario where you have lots of maggots in the berries, because then of course you can't sell them.
And we can apply this directly to a lot of different types of pests. And so one of the things that we've been working on is really understanding these thresholds, or the number of pests that you can encounter in the field, and how that relates to damage. And so we try to develop these thresholds for growers that help you decide when is it worth the economic and So you saw this already very briefly when I talked about cucurbit pests earlier today. Ooh, sorry if I got frozen. But so we have a very clear guides within watermelon for cucumber beetles in particular, where we can tolerate 5 beetles per plant. And there are a lot of environmental factors that influence the movement of the insect in the environment related to temperature, but also the diversity within the area in terms of which crops they prefer or how quickly they make it into your field. So we can learn information about monitoring developmental degree days and temperature to understand the biological potential for the insects to move around. But then we also need to get into our field and be able to identify, are they actually here in my field and causing problems? So as extension specialists, we work really hard to develop these sort of economically informed decision tools about when to sample, how often to sample, and what's the level before you should make an application. And in the past 5 years, across all the watermelon fields that we've been working in throughout the state, there have only been 2 occasions in watermelon where we actually reach this threshold and have to spray for cucumber beetles. And so if you have sort of exhausted all other options, we want you to be able to make the most informed decisions about pesticide use and what your options are and how to best use them. So when we talk about pesticides broadly, so this can apply to organic or conventional, there's 3 different ways really to apply them. One of them is through a seed treatment, and this works for pesticides that have systemic activity, which means they can move throughout the tissues of the plant. So as the plant grows, that chemical moves and can protect those tissues. And this is why neonics have become so popular, because they are very good at moving through water and moving up through the plant. And this offers protection at the onset of when that plant is germinating in the field. when it's usually most susceptible as a very small plant. The second option that we have is through soil drenching. So these are the same types of products that can move systemically through the plant, but instead of coating it around that seed, you can put it in the water and then water it on as you transplant in the field. So this is something that works. Makes more sense when you're using greenhouse transplants. So for cucurbit crops like cantaloupe and watermelon, where you're transplanting seedlings into the field, you can get similar types of protection that can be offered from seed treatments. And then lastly, it's foliar applications, and that's a wider variety of chemistries. They're not necessarily systemic in the plant, so you need to put them on the surface sometimes and reapply them as they wear off. And the routes of exposure here may be similar, though, as to seed treatments and soil drenches, and that can be through contact or ingestion. And so I think this is our first poll question. So what we're curious about is, do you use treated seeds? So hopefully our moderators can pull that poll up. And so yeah, more broadly, do you use seed that is treated with insecticides in your pollinator-dependent crops? Yes, no, or maybe you don't know. And I think we learned that we can leave that up. So I'm going to go on to the next slide. Once it gets to like 60%, you guys could close that poll. And so if we go back to this idea of risk, or what Elizabeth was talking about earlier in terms of how pesticides can interact with pollinators, risk is the way that we quantify this. And so that includes 3 different aspects. Frequency, which is how often are they encountering the chemical. Residue dose, so that is how long is it hanging around. And the toxicity, or how toxic is it specifically to bees. So I'm going to walk through some considerations for limiting the exposure through strategic applications. So that's that frequency issue. Reducing the residue through application rates, and that's that residue dose. And choosing products that are bee safe, and that gets at that toxicity. And you can see how all 3 of those play together to influence the risk that the pollinator may be exposed to. So limiting exposure through strategic applications. So really, some really common sense, in some cases, things you can do to minimize this exposure. Avoid making applications during bloom. That includes flowering weeds. So that may depend on the timing of when the pest attacks your crop, but if you can get ahead of it and apply applications prior to bloom to knock that population back, so that can reduce applications during bloom, that limits pesticide exposure for pollinators. Minimizing drift, so really understanding the spray width when you're applying and understanding how far into the field margin that spray may be moving, because we know that those weeds and neighboring habitats are really important for the insects. If you can't avoid applications during bloom, then apply them in the evening when flowers are closed. This works especially well with cucurbits, where the male flowers close at night, and when fewer bees are foraging. So there are still some bees, bumblebees in particular, that can forage pretty late in the day, but you're reducing the number that can come in contact. And then if possible, maintain a refuge that is not treated. And so that can be something as simple as a pollinator strip, but making sure that that pollinator strip doesn't come into contact with insecticides. The next option is reducing the residue through application rates. So here, this is mixing the lowest rate that has an efficacy against the target pest. So we've done work at looking at Admire Pro as a soil drench at planting for a lot of cucurbit crops, and it is just as good at killing the insect pest at the low rate on the label as it is at the high rate. So you save yourself money by using less product, and you're also putting less chemical out in the environment and reducing that residue. It can also help in prolonging the effectiveness of the chemistry and delaying resistance. And then this last one here is choose products that are bee safe. And so I want to take you to the Midwest Veg Guide, and hopefully I can figure out how to do this and help you find the information on bee safe factors. So someone chime in, can you see the website interface right now of our crop guide?
Yes.
Awesome, thank you. Okay, so there's a lot of different ways that you can navigate through this guide, and I think there's a lot of really useful information. What I'm going to do is just pick an example here. Let me do cucumbers, and I'm going to choose aphids just as an example. And so here what I've indicated is what the crop is and what my pest is. And now I'm going to see all of the options for which I can manage this pest. The very first one is the non-pesticide options, and sometimes these are really well populated and you can get really good information about biological influences of the pest, natural enemies, or like it says, non-pesticide applications. And then you'll have a list of pesticides with a sort of drop down to get more information. And so if you're an organic grower, you can open up, let me see if I can find one here. You can open up a chemical and you can look down, and we have it indicated right here, Organic Materials Review Institute status, yes. So you can find if they are OMRI approved. What I want to compare is belay versus bee leaf. So belay here is clothianidin. This is a neonicotinoid chemical. There's application notes here. The signal word is caution, and if you go to this show more button and scroll down here, we have information about the UC Davis bee precaution rank. Do not apply or allow to drift to plants that are flowering or water puddles. Toxic to other bees. Avoid mix with FRAC 3. So we have a lot of different information here that can impact your decision. So if I'm debating, I have an aphid outbreak and it's at the peak bloom, should I use belay? It has some pollinator warnings. Let's check bee leaf. Bee leaf is specific for piercing, sucking insects. The mode of action is very different. It has no bee precautions. So at this point in the growing season, if I'm concerned about pollinator exposure, this would be a better product to apply, because you can increase that risk. Another way to get to this information is if you go to the production guide, and if you're just curious about, say, the inventory of chemicals you have, you can go down here to the insecticide table, and what this will pull up is a comprehensive list by active ingredient, the various trade names, and the bee precaution is also available here, or you can go directly to the label of the chemical, but it's easier to compare in this situation, and it'll explain it to you. So this is based on research, a lot of times laboratory-based research, but there's a ranking of 1, 2, or 3. 1 is the highest risk to pollinators, so do not apply it to plants that are flowering or water puddles, because pollinators are often drinking from water puddles. And then if it's toxic to honeybee brood or to other bee species. So some of that information is limited to the research that we have available to us. Sorry, I'm going a little bit over, but I wanted to make sure that you knew where to find that information for yourself. And I'm going to take it back to Elizabeth.
Okay, so we're nearing the end here, and so we just thought we would share potentially a busy, overwhelming diagram of all the ways that pollinators, honeybees are highlighted here, but keep in mind there are many other kinds of bees with different lifestyles, right? So they don't all have a big hive, and they don't all live above ground. But so this diagram was actually put together by the team at Purdue, looks like back in 2016. So something you can look at when you have a chance. The take-home message here is that everyone's, in environments where there are a lot of pesticides being used, there's a lot of risks of exposure. And so in terms of what you can do, I think if we could boil it down in a simple take-home message, we'd say select insecticide application types, whether that's a foliar treatment, a seed treatment, or a drench, and the timing. that is most likely to reduce exposure risks or harm for pollinators. And you are going to know what the best approach is going to be for you based on the pests that you are challenged by. And of course, if you want feedback or need support, please reach out to us or your extension educator. Adopt monitoring tools and use the Be Safe insecticides when possible. And this is kind of a common sense one, but always use pesticides judiciously. If you can handle a little bit of damage, or I should say tolerate, please do, because, we're never going to get rid of all the insects, and we do need a few to make a living on the planet. Whoops, Laura, you're muted.
Sorry, too many things to navigate. Okay, so we have the last poll question up. Hopefully you guys can see that and have time to answer it. And actually, while that's up, I can switch to our last slide with our contact information.
We have a lot of participation in this poll. It's still climbing.
Oh, and I noticed we didn't, so for the first one, I think it was about 60% of you answered yes, you use treated seeds.
And we did have we did have a couple of questions that came up. This one might have been answered, I'm not sure. Are there any studies on the time of day application, including night applications?
That's a good question. I don't know about specific studies. I don't know if you know either, Laura. I can think of some examples where they've looked at bees, mainly the difference between bumblebees and honeybees. That maybe the bumblebees can be out when it's cooler. So depending on where you are in the country, that means earlier. I guess the simple answer is I don't know. I don't know off the top of my head.
No, we have never done them here at Purdue. I guess it just stems from the fact that if you're doing these foliar applications with some of the contact insecticides, if the actual flower parts are closed, then you're reducing the amount that lands on that pollen and nectar. So it's going to depend on the chemistry as well. If it's a systemic chemical, it's going to move into those plant tissues regardless of how you apply it. Something like pyrethroids in particular, it just makes a lot of sense to apply them in the evening. You limit impacts on many different beneficial insects.
Great, thank you. There was one question that was asked earlier in the series, and Liz Maynard sent a publication which seemed really helpful. It was a farmer was told that he would gain 50% more production for his crop if he had bees in his field. Does that sound accurate?
So it depends on the crop and it depends on the pollen limitation. But I think that Elizabeth could probably back me up on this. Most of the research that has been done in terms of pollinator limitations on crops would not support that. I guess more specifically, research looks at competition between pollinators, and they find that pollination is not the limiting source. And especially what we've seen in our fields in Indiana is that native bees can make up for not stocking honeybees, I should say, in that sense. They're still getting the exact same yields.
Wonderful. Yeah. Thank you. Those are the questions we have. Again, if you still have questions, feel free to send us emails or type them in the chat and we will save those to answer later. Thank you so much, Dr. Ingwell, Dr. Long, and all of our presenters today. We do have one more poll generally just for the end of this session. If you all could take a look at that. And then I have that QR code I can pull up for the CCAs, if that would be helpful. Great. Looks like we're slowing down. Thank you all for participating in the poll and for participating in the session. The next session will be next week, same time, same place, I guess, virtually. So just look for an email about the sessions and feel free to reach out and let us know if you have any further questions. Anything else we need to share, other moderators?
I think that's it. Thank you.
Wonderful. Okay, that's it, everybody. Thank you so much. Have a great rest of your day.
Thank you, everyone.